Today we're going to look at parallel and perpendicular lines. What I'd like to first do is begin by graphing these two lines on the same coordinate plane. So our first equation is y equals 2/3 x plus 1. It's written in slope-intercept form. So what we're going to do is we're going to begin on 1 on the y-axis, which is right here. There, that is your y-intercept. Then our slope is 2/3. So that means we are going to rise 2 units and run 3 units to the right. And since our slope is constant, we're going to go up 2 and over 3. Up 2 and over 3. And we can go down 2 and over 3. Down 2 and over 3. Our slope is positive, so as the graph, as the line goes to the right, we are increasing. So as the x values get larger, so do your y values. It's a positive slope line. So this equation is y equals 2/3 x plus 1. The other equation is y equals 2/3 x minus 3. So -3 is our start number. That's our y-intercept. And again, we're going to go up 2 and over 1, 2, 3. Up 2 and over 3. Up 2 and over 3. And again, we can go down 2 and over 3. We have several points here, and we're going to connect the dots, and that is the equation of y equals 2/3 x minus 3. So what do you notice about these two lines? You should notice that they are parallel. They will never cross. Both of these lines are parallel. Parallel lines have the same slope. They have the same slope, but what is different? They have the same slope, but they have different y-intercepts. So, if you have equations and you are determining whether they're parallel, what you're going to want to do is rewrite them in slope-intercept form. If you notice that their slopes are the same and their y-intercepts are different, they will be parallel. They will never cross. So now, you're going to be asked to determine whether two lines are parallel. Well, in this question, one of the lines, we know the slope. So this says y equals -3/4 x minus 5. So the slope of this line is -3/4. So what we need to do on the other line, which is 3x plus 4y equals 12, that's in standard form, we have to solve this equation for y. So we're going to bring 3x to the other side. It becomes -3x. And then we're going to divide everything by 4. So y is equal to -3/4 x plus 3. Now we're going to analyze the slope on this equation. This line, the slope is, again, -3/4. So we're noticing that the slopes are the same and the y-intercepts are totally different. So we can conclude that these two lines are parallel. They are parallel because they have the same exact slope, not close to, kind of, sort of. They have the exact same slope and different y-intercepts. Okay, now this is your turn. I would like for you to try this one. So you should be able to tell me what the slope is on this line very quickly, which is, it's already in slope-intercept form. It is -3/4. And this line, what we'd have to do is get this in slope-intercept form, so 8y equals positive 6x minus 24. When I divide by 8, I get y equals 6/8x minus 3. Now, this 6/8 is not the same as 3/4. What you should do, though, is you should make sure that you reduce any fractions, because if you reduce this fraction, both of these are divisible by 2. So if I divided both of these by 2, I get 3/4. So why are these two lines not parallel still? Because one has a negative 3/4 slope, one has a positive 3/4 slope. So these two lines are not parallel, they just have different slopes. One is going in a positive direction, one is going in a negative direction. And they are in different, starting in different spots. So these are not parallel, and we have to just say that they are just not parallel. Next. This question I want to go over with you guys. It's how to write an equation of a line that's parallel to this line, but it contains this point, 1, 3. So the directions are here, but I'm gonna go over it from scratch. So the first thing you're gonna want to do is, when you have parallel lines, you know that their slopes are the same. So we want to pull out this slope, which is 2/3. And if this happens to not be in slope-intercept form, you'd have to get it in slope-intercept form. But since it is for us, we know that the slope is 2/3. Now, we want to contain this point, 1, 3. So the easiest thing to do is jump right into point slope form. And we want to put 2/3 here. And we're going to plug, this is our x1, not the first x, but the x1. So it's x minus 1. And over here is our y value. This 3 goes right here, so y minus 3. Now, this is, at this point, what I want you to do is look at the question. If they ask you to write the equation in any form, they don't specify which format they want it in, technically this is a good answer. But if, in more cases than not, they will ask you to get it in slope-intercept form. This is point slope form. This is point, because we have a point and the slope. So to write it in slope-intercept form, what we would want to do is get rid of this 3. So we're going to multiply this by 3, this by 3, and this by 3. So let's do that. 3 times y minus 3 times 3 equals 3 times 2/3 x minus 1. What happens here are those 3's cancel out. So we have 3y minus 9 equals, and we're going to distribute this 2x minus 2. Now, to get this in slope-intercept form, this 9 has to be added. Okay? So you have 3y equals 2x plus 7. And now the grand finale is to divide everything by 3. Y equals 2/3 x plus 7/3. Now, if you were to graph that line, which would be rather difficult because the y-intercept is 2 1/3. This is really 2 1/3. And if you were to graph the original, what we wanted it to be parallel to, you would see that those two lines are parallel. And you would also notice that this line contains the ordered pair 1, 3. Okay? So hopefully that wasn't too difficult. Okay, next, your turn is to write an equation of a line that's parallel to y equals 3x plus 9, but I want it to contain 2 negative 6. So I want the slope to be 3, because that's the slope of that line, and parallel lines have the same slope. So we're going to jump right into point slope form. That's the easiest form. And the more you write this, the quicker you'll get it committed to memory. So we want to make sure that our ducks are all in the right spot. So we have y minus negative 6 equals 3 times x minus 2. Now we could obviously, two negatives in a row, we know that that's plus. This would be a fine answer for point slope form. But if it says write it in slope intercept form, you have to distribute the 3 and bring 6 over here. So the equation in slope intercept form is y equals 3x minus 12. So if you were to graph this line and y equals 3x plus 9, you would see that they're parallel, but this line passes through to negative 6. Next, we're going to move on to perpendicular lines. Perpendicular lines are lines that intersect and they form right angles, 4 as a matter of fact, such as the rectangular Cartesian plane. So these two are lines that form right angles. So now we're going to take a look at these lines. So first what I want you to do is I would like for you to graph y equals 1/2 x plus 2. So that tells us it begins at 2, and we're going to go up 1 and over 2. Up 1, let's keep that pattern consistent, and remember we can go up or down. Okay, it's rise over run, vertical over horizontal. So that is the line y equals 1/2 x plus 2. Our other line that I'd like you to put on the same graph is y equals negative 2x plus 3. So that one begins at 3, very close. And the slope of this is negative 2 over 1. We can make that a fraction. So because it has a negative slope, we're going to rise 2 units and run 1. So rise, it's a vertical distance over a horizontal of 1. Vertical over horizontal. And that pattern continues. 2 to 1 ratio is our slope. Now, these two lines, they form right angles. If we were to straighten it out, we would see better that there are 4 right angles. So these two lines are definitely perpendicular. And what do you notice about the slopes of these two lines? It has to do with slope. One is 1/2 and the other one is negative 2. Well, you should see that they are opposite signs and they are reciprocals of each other. So perpendicular lines have opposite reciprocal slopes. So if their slopes multiply to give you negative 1, that's another way you can check to see if these two lines are perpendicular. So the product of their slopes is negative 1, and they are opposite, meaning opposite signs, and reciprocal. Opposite and reciprocal. So if we looked at a vertical line is up and down. A vertical line has a slope of, it has an undefined slope, and a horizontal line has a 0 slope. That is an example of two lines that are perpendicular. A vertical line has an undefined slope, and a horizontal line has a slope of 0. Okay? Now, here's some examples of what perpendicular slopes look like. So here's an example 1. It says the slope is 4/5. So the first thing you're going to do, if we want to find out the slope of the line that's perpendicular to this, first we would find the reciprocal slope. So flip 4/5. We get 5/4. And then change the sign of it, so it's negative 5/4. Here's another example. If I give you the slope of -3/8, I believe that says -3/8. We're gonna say it says -3/8. To find the reciprocal, you're gonna flip it, and then you're gonna change the sign of it. So the slope of a line perpendicular to that would have an 8/3 slope. So let's try a couple examples and we'll be done. How would we write equations of lines that contain certain points but they're perpendicular to another line? So the first thing we're gonna wanna do for this question here is we wanna find the slope of this line. Right now, it's in slope-intercept form, so I know the slope is 4. The slope of this line is 4. M is 4. But I don't want that slope, because the directions don't say parallel, it says perpendicular. So perpendicular, it's a sign for perpendicular, would be -1/4. That's what you thought, you're right, -1/4. But we want this to contain 4, 1. So again, we're gonna do the same process. We're gonna start with point slope form. We're gonna plug -1/4 in for the slope, and we're gonna plug 4 in for our x1, 1 for our y1. Okay, now this would be an okay answer if they said write it in point slope form. But if it says slope intercept form, we've got to get rid of this 4. So let's multiply this by 4, this by 4, this by 4. So we get 4y minus 4 equals, the 4's cancel here, we have -1 times x and -1 times -4, which is a positive 4. Now we want to bring this 4 over, we're going to add 4. 4 plus 4 is 8. So we have 4y equals -1x plus 8, and then divide everything by 4. So our answer is y equals -1/4 x plus 2. 8 divided by 4 is 2. And all the steps are here. You can see that. Here's one I would like for you to try. I want you to write an equation of a line that contains 1/8, but it's perpendicular to 3/4 slope. So the slope would have to be -4/3. If you flip it and change the sign, you get -4/3. So we're going to use y minus 8 equals 4/3, -4/3, times x minus 1. And again, if they ask you to write it in point slope form, that would be a good answer. But the question says specifically, write it in slope-intercept form. So what I want to do is first, I want to get rid of this 3. So I'm going to multiply this by 3, this by 3, and this by 3. Because I want those 3's ultimately to cancel. So I have 3y minus 24 equals, and this is a -4 times x minus 1. These 3's canceled out, so I still have my -4 here. So distribute the -4. And now add 24 to get this with the y-intercept. We want to find out what the y-intercept is going to be. We still don't know it though. 3y is equal to -4x plus 28, and then divide by 3. So what we know is our y-intercept is 28/3, and our slope is -4/3. That would make this line, if we graph this line, and we graph this line, we would see that they're perpendicular. They form 4 right angles. And you should double check that the slope of this line, 3/4, and the slope of this line, 3/4 times negative 4/3, when we're multiplying, they need to add, to multiply to be negative 1. That's when you know that they're perpendicular. That concludes our notes.